How and where is a star born? The birth of a star is a complex and fascinating process that involves the collapse of a giant cloud of gas and dust, known as a molecular cloud. When a molecular cloud collapses, it begins to spin faster and faster, eventually forming a spinning disk of material around a central point. As the material in the disk comes together, it begins to heat up and contract, eventually forming a protostar. As the protostar continues to contract and heat, the temperature and pressure at its core increase. When the temperature and pressure reach a certain point, nuclear fusion begins to occur, and the protostar becomes a star. And this is how is a star born. The nuclear fusion process releases a tremendous amount of energy in the form of light and heat, which helps to stabilize the star and prevent it from collapsing further. The process of star formation can take millions of years to complete, and it is not a uniform process. Different parts of the molecular cloud may collapse at different rates, leading to the formation of multiple stars in a single system. Additionally, the size and mass of the molecular cloud and the rate at which it collapses can affect the properties of the resulting star, such as its size, mass, and lifespan. At the time of the Big Bang, the temperature was unimaginable. 3 minutes after the Big Bang, the temperature dropped from 100 octillion, 100 non-million, degrees Celsius to 1 billion degrees Celsius, and then light elements were created in the Big Bang nucleosynthesis process. Protons and neutrons combine to produce deuterium, an isotope of hydrogen. Most of this deuterium then fuses to form helium, and then significant amounts of lithium are also formed. In this way, at least 20 million years have passed since the origin of these elements and the first stars born in the universe. At present, with the number of stars that we see in the sky, a single person can't count them. There are at least 40,000 billion stars in our Milky Way galaxy alone. And billions of galaxies like our galaxy and many times larger are scattered in space. But these stars were not born at all. No stars were born in the 2.1 billion years after the Big Bang. Some light elements like hydrogen, helium, and lithium existed. These gases floating in space are called cosmic gases. At present, with the help of modern technology, considering the surrounding conditions and conditions at that time, how stars originated from this cosmic gas has been tested through simulation. The simulations showed that these ancient cosmic gases tend to gather in different places due to their gravity. Then these collected gases try to converge to a point and then generate heat of about 1000 degrees Celsius. Hydrogen atoms then accumulate in this dense and hot gas assembly, and hydrogen molecules are formed. These hydrogen molecules then begin to radiate heat and cool the densest part of the gas stream. The temperature of that dense space then becomes around 0 degrees, although the current star birth temperature is about -250 degrees. Because now cosmic dust and other heavy elements make the space even cooler. As a result, the gas pressure in that area decreases, and more gas comes from the surrounding area, and accumulates at that place, creating a gas stack. As this huge gas pile did not emit any light, it was not possible to see it in ordinary light. This condition is commonly called a dark nebula. Currently, infrared or radio telescopes are used to see such places. This temperature drop is essential for any star formation. When the denser part of this gas cloud is gravitationally drawn toward its center, star formation begins. The mass of these centers is at least 10,000 times heavier than the Sun. Being attracted towards the center, this cloud again splits into several parts to form several stars. Their mass is usually 10 to 50 times that of the Sun. But the early stars were more monstrous. A newly formed star in this state is called a protostar. And it takes about 1 million years to form. Now it is being said, if it takes billions of years to form this protostar from gas, and if that cloud of gas is not visible, then how can we understand what happened? Almost all cosmic gas plumes emit infrared radiation, which is produced during protostar formation. These can be identified and observed with various telescopes. These newly formed stars are covered by a cloud of gas. And at the same time, a bunch of stars is born from the same cloud. The several protostars that form each have different gravitational forces and identities. This force causes the surrounding gas clouds to collapse into the star. As the gases radiate their kinetic energy as heat, the temperature and pressure of the core of the protostar increase. When its temperature reaches several thousand degrees, it starts emitting infrared radiation. Then the pressure and temperature of its core rapidly increase, and eventually, the protostar reaches a stable phase and no more gas is attracted to the core. The mass of a protostar is only 1/100th of its full form. But it serves as the basis of all stars. The star now begins thermonuclear fusion at its core, and this creates a stellar storm that protects it from adding any new mass to its core. This protostar can now be considered a young star, as its mass has now stabilized. The Sun is a medium-sized middle-aged star. When the young star begins to radiate heat and light through the fusion process, powerful interstellar storms are formed, and in most cases, gas streams are ejected from the poles of the star and are easily seen with radio telescopes. This initial phase of the star is called the T Tauri phase. These storms form a giant disk of gas around the star. This disk rotates from being attached to the star and gradually merges with the surface of the star. Meanwhile, energy radiates from the disk and the star where it meets. Gradually this disk disappears and different planets are formed by condensing in different places of this disk. During the T Tauri phase, the young star loses about 50% of its mass and then stabilizes to form a mature star. Hence it can also be called a pre-evolved star. These stars start life with a relatively low temperature, but over time their temperature increases and they take on a bluish appearance. How fast this happens depends on their initial mass. Many massive stars go through the T Tauri stage very quickly and become mature stars. These T Tauri stars are also surrounded by the cosmic cloud in which they were born. Different nebulae or star birthplaces are therefore colorful, due to the presence of many types of gases and elements, and appear clouded. The birth of a star is a complex and fascinating process that involves the collapse of a giant cloud of gas and dust, known as a molecular cloud. When a molecular cloud collapses, it begins to spin faster and faster, eventually forming a spinning disk of material around a central point. As the material in the disk comes together, it begins to heat up and contract, eventually forming a protostar. As the protostar continues to contract and heat, the temperature and pressure at its core increase. When the temperature and pressure reach a certain point, nuclear fusion begins to occur, and the protostar becomes a star. The nuclear fusion process releases a tremendous amount of energy in the form of light and heat, which helps to stabilize the star and prevent it from collapsing further. The process of star formation can take millions of years to complete, and it is not a uniform process. Different parts of the molecular cloud may collapse at different rates, leading to the formation of multiple stars in a single system. Additionally, the size and mass of the molecular cloud and the rate at which it collapses can affect the properties of the resulting star, such as its size, mass, and lifespan. In summary, star-born is a complex process that involves the collapse of a molecular cloud and the subsequent nuclear fusion at the core of the protostar. The properties of the resulting star are influenced by the size and mass of the molecular cloud and the rate at which it collapses. Hope this helps. Like the videos and please subscribe.